Welcome to the PHS Digestive System Review, Part 4. We have now reached the small intestine. Acid chyme has entered the small intestine from the stomach, and we can see it right here. As it travels in the small intestine, our acid chyme is going to get chemically digested. And all of the macromolecules are going to break into the smallest subunit form. Please note that the small intestine is known as the major organ of chemical digestion. There are digestive enzymes in the intestinal walls, but the small intestine is aided by the three accessory organs: the liver, the gallbladder, and the pancreas. The liver makes bile. So bile is produced in the liver and sent for storage in the gallbladder. As acid chyme enters the small intestine from the stomach, the bile will then be released from the gallbladder where it was stored through the common bile duct and enter into the small intestine. Additionally, the pancreas will release pancreatic juices, which contain 28 digestive enzymes, as well as sodium bicarbonate. Sodium bicarbonate is necessary to neutralize the acid in the acid chyme that is entering from the stomach. The stomach has a pH level of about 2 because of the hydrochloric acid, whereas the small intestine has a pH level somewhere between 7 and 8. The sodium bicarbonate that the pancreas releases through the duct is what allows the small intestine to change pH levels and be closer to neutral rather than acidic. The 28 digestive enzymes that are released from the pancreas aid the intestinal digestive enzymes in breaking down the three macromolecules. The three macromolecules I'm talking about are carbohydrates, proteins, and lipids. All three of these macromolecules are going to turn into their subunit forms. Carbohydrates are going to be chemically broken down into monosaccharides. Proteins, which are in the polypeptide form after their chemical digestion started in the stomach, will now be broken down into their subunits, amino acids. And finally, lipids are going to be turned into their subunits of fatty acids and glycerol. Recall that bile is necessary to help break lipids down as it works to emulsify lipids, breaking large pieces into smaller pieces, which allow digestive enzymes to do their job. Also recall that there are different digestive enzymes working on the three macromolecules. Carbohydrates are broken down by amylase. Proteins are broken down by peptidase, and these are the specific names of the enzymes, and lipids are broken down by lipase. And recall that they use bile to make them smaller, which allows the lipase to break the lipids into their smaller pieces. Once all three of these macromolecules are broken down, which occurs in that first section of the small intestine, the undigestible material will continue traveling through the small intestine. The small intestine structure allows absorption to occur. So all of these subunits are going to be absorbed in the remainder of the small intestine. The structure aids this because there are tiny finger-like projections called villi that are lining the intestines. Additionally, those villi have tiny villi, microvilli on them. All of that allows for the movement, which is propulsion, and more mixing, physical digestion, which allows absorption to occur, giving the large surface area of the small intestine the chance to come in contact with our subunits and absorb them into either the bloodstream. For monosaccharides and amino acids, they go into the bloodstream and then onto the liver. And for fatty acids and glycerols, those will go into those special lymphatic ducts into the lacteals. So once all of the traveling has occurred, at this point, when the indigestible material enters the large intestine, all of our subunits should have been absorbed. At this point, we only have indigestible material, so materials that our body cannot digest, as well as fiber. Recall that fiber works as roughage in our system. It helps move things along. It allows water to remain in the forming feces, which is not formed yet. Now, as our indigestible material moves through the large intestine, and recall that peristalsis works slightly differently in wave-like motions in the large intestine, as this is occurring, we will have absorption happening in the large intestine. So absorption at this point is of water, salts, which are a mineral, as well as some vitamins. There is bacteria living in our large intestine, and it is mainly making B12, vitamins B12 and K. And because those are released by the bacteria, our body is able to absorb them through the large intestine. Peristalsis continues to work, and that indigestible material is sent to the rectum for temporary storage, where the feces will finally form, and then out the anus for expulsion or elimination. Please recall that the rectum and anus are both part of the large intestine, but they are outlined here as they have distinct roles to play in the digestive process, and that completes digestion.